Hello, everyone, and welcome to another Community Office Hours. I'm Sam, and our VP of Engineering at Moderne, working on the core refactoring technology. And this is my colleague, Justine, who
Hi,
is our
everyone.
AI researcher and AI engineer. What do you call yourself these days? Do you call yourself an engineer, a researcher, a research engineer?
I really flip flop. I also go from AI to ML. I just
Hmm.
it's really like seasons. I think it depends what I'm working on.
So as we get into warmer weather, it's the season of ML, would you say?
Yeah. I don't know, with like generative AI exploding like it did, I felt a need to say ML,
Yeah. To,
but
like, differentiate a little bit?
yeah, exactly. But then I did end up doing some AI as opposed to ML for some stuff that we're going to show later. And some like maybe AI is better fitting.
Mhm.
And it is easier to explain to people AI, or rather they'll have the idea of the concept before.
Right, right, and probably some misconceptions along with,
Definitely.
some accurate preconceptions. So, now that I have you here, can you, confirm or deny the long-held rumor amongst engineers that AI is just if statements nested sufficiently deep?
Yeah, I mean, 90s AI, yeah, absolutely. And this is something I say about Moderne and Open Rewrite all the time. It's like even before I joined, you guys were doing AI. Like AI is just a smart algorithm, and so this is pretty much Open Rewrite is an algorithm at the end of the day, and it has, it's intelligent, right? It does the thing it's supposed to do. So that for me is AI, but maybe I'm a little bit too by the textbook. I think now AI is more used to talk about generative AI,
Mhm.
which we do some of, but that obviously wasn't the case before I joined. And yeah, so
Yeah.
I mean, you're not wrong.
Just not entirely right either. Very diplomatic of you, Justine. Okay, so
Thank
before
you.
we get into more AI subjects, I do have just a couple announcements to go over this week. And I should share my screen so I can give those announcements. There we go. So as I've been mentioning, we will be at Dev Nexus. At this point, this is what, next week? So if you're not already signed up for it, it's probably too late. And if you are signed up for it, Jonathan and Olga look forward to seeing you there.
And me.
Uh, oh, and Justine, you're also
Hmm.
going to be there. Great.
Yeah,
Yeah.
presenting
So
on Thursday.
nice, nice. So if you like today's subject matter, be sure to go to Dev Nexus for more. Aside from that, we have a new blog post on the Moderne.io site introducing the Moderne Dev Center, a pretty cool new piece of functionality in the Moderne platform for quickly visualizing the status of various initiatives you might be taking across your organization and acting upon those visualizations. Doing things like migrating you to the latest version of Java or whatever other recipes you might want to pin there as you track your organization's process on various initiatives. So check out that blog post to learn a little bit more about that. And similarly, we also have a new YouTube video, if that's more your speed, on the same subject. So look forward to uh, seeing either of those. So, Justine, now that we have the announcements out of the way, you're
Hmm.
here to tell us a bit more about artificial intelligence at Moderne. Uh,
Yes.
and I think the very first thing we had you do when you joined was improve our recipe search. Can you tell us
Hmm.
a bit about that?
Yeah, absolutely. Let's share my screen so I can show. There you go.
There we go.
All right, so let's start with the marketplace, right? That's where everywhere goes. So I think there was a need, if we go here and remove the AI assisted search to see what were the kind of problems we had before. Um, One key issue was typos. And, obviously you can go back and go fix your typos, but in this day and age, we want results live. And so let's see if we put a typo here, upgrade Java. As you see, nothing comes up. And it makes sense because what we had for search before, and still have, as you see, because we can always remove the AI enabled search, was a keyword matching. And so Upgade basically made the whole thing go sour and wasn't able to find the recipe. However, if we go and enable it, Upgade Java works, and we find some stuff here. So at least we have some recipes here where it understands that update, it understands upgrade, and it finds some stuff from there. Another one that was failing was method invocations. So here it finds one recipe, but the one I really wanted to find when I typed this one, and this is actually something that was happening to one of our customers where they were looking for that recipe, didn't find it because they wrote find method invocations, and they were looking for find method usages. That's actually the name. And so by doing keyword matching, it wasn't able to find it, as you see here. It finds another recipe, but this is another one that's AI, not the Java recipe that we're looking for. However, if we turn on AI-assisted search, now we find what we want. We find method usages, and we can also see find method declarations. So it understands a little bit better that we're looking for this, basically the synonyms. And so the way that it's able to do that, if you want some background, is that it basically takes the keywords, the words, it tokenizes it, and it puts it through an embedding model. So what you get as the output from that AI model, which is the embedding model, is a vector. So a list of floats, if you want, even to make it simpler. And so this list of floats, basically, which is a vector, you can get then the distance in between the query vector and the document, the recipe, the element, whatever you're searching onto. And by looking at this distance, you can now get an idea of what are similar and dissimilar, because things that are similar are going to be close, things that are dissimilar are going to be further away. And so what's interesting about these embeddings, and this is true for embeddings for natural language as well, you might think that, like, say the word love and the word hate would be far apart, but because they both refer to a sentiment and emotion, they're actually going to be pretty close. But because we're talking about, multidimensional, they will differ obviously on some dimensions, but on others, which might be like the sentiment dimension, it's going to be very nearby. So I think it's important to visualize it like that when we talk about embeddings, and that's really when you can see how useful they can be in this sense. So this is here. If you ever are interested in doing, your own AI in any way, and you don't know where to start, there's so many open source models out there. There's some closed source as well, but they have the marketing ability to get those names to you if you're looking for them. But for the open source, I think a really good resource is Hugging Face. So if you go to Hugging Face here, and you can even click in and say, okay, well, I want something for text classification. So that could be that you want to classify a tweet as a positive or negative. Like, was it something nice or was it something mean? Then you could use text classification. Maybe you want to do question answering. So that would be a bit like a Wikipedia that talks back to you and gives you answers to your questions. Then you could click here. And you have all these different models. You can see it then. Yeah, go for it.
So did we use one of these models for the AI recipe search?
Absolutely.
And if so, which one?
Yeah. We use two models, actually. So we saw here in the text classification, this is the second model that we use. So what's interesting about the setup that we did is that we needed it to be quick, right? When you search, you don't want to have to wait 1 minute. That'd be way too long. So to make it fast, we do 2 steps. So we use a smaller model, which is not this one, but it is from the same academy. This is the Beijing Academy of AI. And so they particularly were looking at models that do embeddings for retrieval, because embeddings out of the box can be used for generations. That would be like the next step, the next layer in the model. Or if you want to do something like retrieval, you have to make sure that you train for that retrieval as well.
What do you mean by retrieval?
Finding
Okay.
stuff. Yeah.
Okay.
Like a top K ranking, all that's retrieval, right?
I
You can
see.
decide to retrieve 1, 2, whatever you want. But yeah, finding, I guess, is a synonym for it.
Hmm.
And so yeah, so that was the first step. We took a smaller model that we used to get the embeddings for all our recipes. So we used the recipe name, description, and from there, we are able to also cache those, which is why we are able to do this so quick. So whenever the query comes in, it's only time to look at the distance, which that's super quick because you don't have to actually compute any embedding other than the query embedding because everything else calculated. You do that, and what you can do basically is like remove all the ones that first smaller, less good model will be able to say, no, for sure, that's not what they're looking for based on the query. Once you have now that smaller set, we use this model here to be able to then really go in and find with a fine comb. Is that the expression? To go
Yes, that
find.
it with the fine tooth comb. Yeah. So
Okay,
just to
I
be
thought there
sure
was
that
truth in
I'm
there.
picturing how this works correctly,
Mhm.
we you get this model, which will transform text into vectors, multidimensional vectors, and we feed all of our recipe names and descriptions into this. So we have vectors for all the recipes that are loaded in the catalog.
Mhm.
And then a search query also gets turned into one of these vectors, and we say in geometric distance, like you would calculate in freshman high school, how far from this point to this point in this multidimensional space, and anything within a certain distance is counted as a result, as a hit, and
Yeah,
ranked by the distance.
exactly. And it's
Cool.
in this. What's also nice about this is we don't have a threshold on the distance because that can vary based on like how if the query is a little bit
So you just go with
unexpected.
the top in closest in order of
Exactly.
distance. Yeah, makes sense.
Exactly. Yeah. And so then the next step is one that we can't cache
Hmm.
because we'll have to pass in the query and whatever recipe we're looking at. And then we get a score on how likely it is that those two are related or do similar things.
And is that's still from this first model?
That's the second model, the one right here.
I see.
Yeah, exactly. And so that one can be cached. So that's a little bit more expensive. But because we already have that first filter, we're able to, accept that it's going to take a bit longer and still get results really fast overall once we have those 2 steps done.
Hmm.
And if you thought that wasn't enough steps, I raise you a third one, but that one's done
Okay.
not AI.
Uh-huh.
Once the platform gets those results of those recipes, it reorders them based on how many recipe a recipe contains. And this is done because we want to put forward, and most of the time when people are searching on platform, they're looking for larger migrations. And so this is what we want to do. So if we're seeing, upgrade to Java, we want upgrade to Java 21 to be higher, and it will be higher than all the other migrations to Java versions because Java 21 migration contains all the others. So
Hmm.
it's always going to be larger.
Hmm.
So that's another extra step, which you get what you want from the AI, and then you tailor it to your use case, which I think is always
Right.
important to be creative about.
And I imagine that this takes a lot of GPUs and very specialized hardware to run.
The running part actually is really interesting. It's we only did it on CPU, but the training part, yeah, you really need a GPU for it to be that good. There's some models that I'll talk about later, which those ones didn't use a GPU because they were older models before
Hmm.
we had such great GPUs that we do now,
Hmm.
and those were, but basically all except one model we use are all trained on GPU.
Much newer ones, but just so operationally, the model training has already been done by the Beijing Institute of AI. We
Hmm.
take their model, and it's inexpensive to run that on a CPU as a sidecar to one of these processes.
Exactly.
Yep,
Yep,
gotcha.
you got it. So if you want to learn more about this, there's a blog that we did which really encapsulate a lot more of the nitty-gritty details and how to choose a model for you and the different parts that form this thing as a whole. which I recommend you go read if you're interested in this.
Yeah, and I'll go put that link in chat.
Thank you.
Okay, so I get asked a lot when I'm talking to customers or clients or just people in general about using AI to make code changes. I mean, I'm a fan of GitHub Copilot myself. I would miss it if I didn't have it anymore. Um, what have we done with using AI, maybe now in the space of generative AI, to make changes or to actually make code changes?
Yeah, for sure. When I first started talking with Jonathan, I actually met him when I was doing my master's at Mila, and he came to give a presentation on Moderne. And at the end, we just started talking about how we could bring AI to Open Rewrite in Moderne. And, ideas started kind of flashing. And so I think what's great about, or very, very practical rather, about a recipe is it's itself, an algorithm. It's itself something that could call another method. And so that's basically the idea that we took, where you have a recipe that takes in the LST, and at precise moments uses the AI when needed. So to be a little bit more concrete about this, let's talk about this recipe where the recipe basically goes through the code, finds all the comments inside the code, and uses an AI to predict what language that comment is in. And when I say language, I mean English, French, Japanese, etc. And so you could get something that looks like this after it runs. But this is a recipe run. So we go back to the recipe. Here I took this is Spring Pet Clinic, but with some added comments in French, because you'll see we'll need it for a demo later as well. And so when you go back to the visualization, oops, that's for later. Oh, did I lose it? There you go. Then that other here is French, but if it's under 5%, we don't show it.
Just group it all into others. You need to go write a lot more French comments for the
I know, right?
visualization to choose to show you French specifically.
Yeah, I only put 3, I think, so that would definitely make sense. And so the unknown ones are basically when the model wasn't sure enough for us to say, okay, this was in English or in French or whichever. And this is not uncommon because the model that we're using wasn't trained on code necessarily. It was trained just on languages. And so it misses, if ever we comment out a line of code, that's going to make it very confused. If it's not in the training,
maybe where some of those unknowns are coming from.
Yeah, exactly. Definitely.
Or maybe you just need to do more of include Java and C++ and such in the training data set, and then it could point out to you when you have commented out blocks of code.
Yeah.
And that could be handy. Often it would be a code smell or an anti-pattern to have big blocks of commented out code checked in, as that could indicate an incomplete refactoring or just distraction. If it's commented out, it's not actually running. Why are you checking it in? So that could be a neat recipe to have. Go find me.
I really like that.
Yeah. Go find me all the places where code is commented out. It might indicate that that piece of the project is unfinished, or an engineer set it down in the middle of working on it, had to run off to something else, or just that there's a bit of mess that could be cleaned up.
Mm-hmm. Definitely. Yeah, I really like it. And I could see that being not too hard to do either. So yeah, I'm going to add it to the list. Good ideas. This is truly live. Sam has never talked to me about this. This is amazing. So just to give some also visualization of the models, we talk about this recipe being able to use AI. So here you have
this document in a little bit.
Yeah, for sure.
Thank you.
Thank you. So here we have the LSTs that get fed into the recipe. Nothing new here. But the recipe basically will be able to walk down that tree and decide when to make a call to the model. So in this example of the comments, it sends just the comment text, sends that to the model makes its prediction, sends it back to the recipe. And then that recipe is able to produce a data table with which we can then do the visualizations that you saw after, which doing visualization on the platform is so fun and quick and easy. Shout out to Kyle and whoever worked on that. Really like the most smooth process ever.
I imagine you were also already familiar with Jupyter notebooks, right? Which is just
Maybe
backing.
that's why I like it so much. I'm like, yay, no Java, back to Python.
And I'm like, ugh,
That's
Python.
a fair point.
Yeah, if you have a science or data visualization background, yeah, you're probably already familiar with Jupyter notebooks, which are the underlying technology for all of the visualizations on the
Definitely.
platform.
And all the packages also, I know them well, it's so easy. So this is basically the idea behind it. And so then the sky's the limit, really, what you can do for a model, or maybe the compute is the limit. You can have, a model that does what you want. So in the example that Sam gave, that model would predict, is this string code or is it natural language or is it half-half?
Mm-hmm.
And what we could call this model in both the example that Sam gave and the one where we look at the distribution of natural language in comments, it's what we call a classifier model. And we call that a classifier model because it takes in as input something. It doesn't necessarily have to be text. It could have been an image, but in both those examples, it's text. And from there, it outputs probabilities of what class it's in. So for the language one, I forget how many languages, but like between 20 or 25 possible outputs, basically. And then I added one for unknown if I wasn't satisfied with how sure it was. So here you see how it's like pretty much well distributed between the three classes. I would probably say, I rather put this as an unknown as saying, no, I'm for sure this is a class 3.
Mm-hmm.
So that's basically the idea.
Mm-hmm.
Yeah, and then we can go even further with other recipes. To go back to the embedding model, so, as we said, this model and the recipe can be anything. And so in this case, let me get rid of that. There you go. In this case, we have the model, which takes in as input text and gives us back that vector of floats I talked about. And again, it doesn't have to be text. The input can be an image. But since we're working with code, pretty much everything is text that we deal with when it's time to pass it to the model. And so one of the cool things you can do with embeddings, yes, you can do distance, and that's useful for retrieval, but you can also do clustering, which in a way is kind of like doing distance, but many, 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 many times, and getting these boundaries, basically. And so if you wanted to have a nice way to visualize this, big set of documents, text, whatever it is, you can take these, project them into a 2D space, and from there, you can use a k-means to basically find, okay, I think this is in cluster 1, this is in cluster 2, this is in cluster
So
3,
the
cluster 4.
clustering operation happens after it's reduced from a 500 dimension vector to a 2-dimensional vector. Is that right?
Yeah, you can do it before and after, particularly on what I'm going to show for the recipe. I found there's no difference from one and the other, which is actually a good sign that the 2D projection works as a plan, because that is also an algorithm.
How does that 2D projection work at a high level? Like going from 500 dimensions to 2, or in large number of dimensions to 2, it's not obvious to me as a naive engineer how I would begin to approach that problem of vector space reduction, I guess,
Yeah.
is the way of
Yeah.
referring to that.
Mm-hmm. Yeah, I don't know. There's TSNE is one of them, and then there's another one that's escaping my mind right now, which is ironically the one we used because it was slightly faster than TSNE.
Yeah.
But it's basically an iterative process,
Uh-huh.
and there's some really cool blogs, and I'll probably have to dig for it. There's one
Sure.
that was really nice about it, and I'll post it in the comments of the YouTube.
All right.
You
Well,
guys can see my personal link if ever.
my scientific inclination to understand is wholly unsatisfied. But as an engineer, I'm like, you get the same clusters before or after? Great. I don't have to care about the other details.
That's pretty much how I went with this as well. But yeah, no, it's pretty cool. It's a fun read, but yeah, basically it's an iterative process, and I was like, great, good enough. Is it quick? Perfect. Let's go. So I'll make sure to share those because for those people who are a bit more interested in the math behind it.
Cool.
So we ended up using the ones before just out of convenience, and then projecting it basically. And like that, I was less worried also of any noise that came from the projection since I could still use the first one. So how does that look when we actually use it for for a recipe? So I have this recipe before I go and show it actually. So this recipe would go and find all the method declarations. It would take that text, send it to the model, get the embedding, put that in a data table. And then what the visualization does, it takes all these embeddings and then clusters them. But what's fun about it is you get to walk around and see what they are. So it gives you a nice bird eye view of your code. Sorry?
Can we zoom in on this? I find it a little bit. Yeah, thank you.
Especially the text here. We're going to zoom in a lot so we can truly take a walk through the park here. So here you have the k-means, which just means the numbers don't mean anything other than they are from that group. And you can see that the view ofs are all together. And so there is some dedupe here that's being done. So if the method is exactly the same, you only see the 0.1s. So these are all different view ofs, but clearly what was inside that code and the name also of the method was close enough for the model to have an embedding that's close to each other, and that's why they're a cluster next to each other.
So just to be clear, what we're categorizing and clustering method invocations?
Declarations.
Declarations. Okay. So this is a view across your code base of what kinds of methods are being declared.
Exactly. That's it. And it uses also the text inside, the actual code, inside the method declarations. So if you name your method something else, this is a nice way to go and find that you're like, hey, those two methods are right next to each other. The names are similar. Could we have reused one of them for this other part in the code? So that's just one use case. But really, I like it because it gives you kind of a bird's eye view of your code and might make you aware of patterns that you weren't. And so for someone who's maybe, a project manager or higher level developer that's not actually in the code, or even someone who's assigned to a new project, this is a nice added thing. And so you can so you see here, there's also find first view of, which are next to the view of. I don't know why those ones got put next, but here you have the trait errors right here.
Well, you can see that they were assigned to a different group, so their kind of placement near the green group might reflect similar structure of implementation or something like that. But they were clearly categorized as not belonging to that group, even if they are surrounded by green points.
Exactly. Yeah, and like you said, right, this is like multi-dimension, so they can definitely be, if we have it here, but then you turn, they could be far apart, but over here they look right next to each other. So let's continue to walk down the park. Here we have all our get IDs. Here the display names and the different getters are here. And I forgot to mention this is run on Open Rewrite the Analysis repo. Just one. You can run it
on rewrite static analysis or on rewrite analysis?
Rewrite analysis, yeah.
Gotcha.
And you can run it on more repos than this, or maybe more larger repos. So you can do multiple small ones or do one large one. It does get a little bit busy the more you have, but you will be able to see everything all at once as well. I kind of like this amount because it makes it, it's easier to walk through. Let's see if there's anything else that's interesting. Maybe those little red ones. So these are about the files and the paths. are all together. Checksum is near path and file, which I think is
Feels
relevant.
appropriate.
Sorry?
That feels appropriate to me
Yeah.
since they're both kind of file system and file content oriented sort of operations.
Yeah. And where are all the visits? Because those tend to be together as well. Aha.
Oh, it's the yellow group.
The yellow group. So here we have all the visits, which is, a key part, fundamental part of Open Rewrite framework.
Mm-hmm.
So yeah, you have all the visits here. Have fun putting in a new repo and then looking through it. It's more than just pretty, it's actually useful. And right now it's only for methods, but I just need to take 10 minutes to make it for classes as well, which I think could be interesting as well.
Yeah, for sure. I think the class view, I mean, method is a higher level of granularity than classes. So I think in several of the scenarios you mentioned, of like trying to understand a new code base or see the relationships between different parts of code, I'd probably start at a class level of granularity and then want to drill down into methods. Yeah, I look forward to seeing that.
Mm-hmm. Absolutely. All right. And so to talk about a third recipe that we have that uses AI, this one is more recent. So we have this customer who has comments that are in French because they are a company that mostly speaks in French. And what happens with their files throughout, the life cycle over multiple years, we're talking legacy code here, there will be sometimes characters that get misencoded. So like accents on letters, or CCZ for those who speak French, those kind of characters, basically they got misencoded. And sure, that's annoying for readability, but it also became an issue for them because they could not generate documentation automatically from Java docs. It would not compile if they had those Unicode misencoded character in there. So we're like, all right, let's do a recipe for this. And that's what we did here. So this is on the Spring Pet Clinic example where I've ingested in there little comments that were misencoded.
Can we zoom in on one of these comments?
Yeah, for sure.
Since it's often just one character difference in here. Yeah, there we go.
There you go. And so it could be just sometimes they were misencoded and replaced by an interrogation question mark, or sometimes they were replaced by that, Sam, you would know how it's called, the Unicode and
the little Unicode diamond of confusion. There's probably a more
I like that name, the diamond of confusion. That's perfect. So the diamond of confusion, or the question mark here, is how the code would look like in the wild for their repos. And so basically what that recipe did is that it, same concept as before, go through the comments. It actually calls the first model, the one where we try to classify what language the comment is in, because you don't want them to correct stuff that it shouldn't. So if it says, yeah, I think it's in French with this much, confidence, then you say, okay, next step, are there misencoded characters? All right, next step, go and fix them. And so the fix them part, this is the part that I was
misencoded. So the first step, the categorization of French or not, that's one model. Is the presence of misencoded characters, is that another model?
No, that's just contains. Gotcha. String dot contains.
Fair enough. Fair enough.
And so from there, then we that's the model that I was talking about that wasn't trained on GPU, because it's actually, I wouldn't call that. I guess I could call it machine learning. I don't know. It does use past data. Yeah, I'd call it machine learning, which is the difference between AI and ML. So it uses a dictionary, basically.
So you're saying the difference between AI and ML is what exactly?
It learns from past data.
I see.
Yeah. So the clustering is ML because you need to have that past data to be able to say what goes with what, basically.
I see.
If I give you only 1 point, you don't know what cluster is in. But if I have all the clusters already defined and I give you 1 point, then you can decide where it goes by looking where is it nearest by, basically.
I'm feeling a little bit confused by that. Are you saying that just like k-means is itself AI?
It's when you use it as a predictor.
I see. I
Yeah.
see.
Because if I give
Okay.
you, you need to have the past things that are decided for
Mm-hmm.
before being able to predict. If I give you, that next dot to decide what color it should be for whichever group it is.
All right. Yeah,
Um,
that makes sense to me.
so forgot my point. AI, ML. Oh yeah. So the dictionary.
Mm-hmm.
So the dictionary is not AI or ML. The dictionary I'm referring to rather is it's a dictionary that looks at number of occurrences. So it basically scrapes the whole internet, and this is in the data before you get the actual occurrences. From there, you count how many times you see a word. And so this is a word, not a token, for those who are a bit more familiar with transformers or more recent models in LLMs, large language
Mm-hmm.
models. Um, so this will look at the number of occurrences that a word has appeared. And from there, it's able to basically look through all those words, take the distance in the sense of how many characters you need to change to go from that word, and finds the most probable based on that. But it
Mm-hmm.
also uses, if there are two words that are as many characters away, but one is more probable, then return that one.
Right.
And so this is a very simple model. This is what I meant by it could run on a CPU because it just
Right.
has to deal with the data. There's no like gradient descent. This is simple, but I was kind of like thinking it wasn't going to work at first, but I was trying to find
Really?
something quick and it worked great.
What intuition led to your skepticism about this?
New equals better. No,
Fair enough.
joking. But yeah, no, truly, like I'm half joking. I could have used something that was more generative and actually say, fix this sentence and have it fix it. But that takes time.
Right.
And that takes, on CPU running that also, that definitely like brings it down. And so the whole idea is to kind of just like, let's try everything we've got and see what works best. And so whenever I'm working on a problem, I'll probably try, 4 or 5 different types of models as well. I had a first iteration of a dictionary that was much smaller, and then I was able to find a larger dictionary, which had more words, including a little bit of tech words, which is really useful for comments. And yeah, that's how we were able to basically fix that. And so what's good is that now they're able to generate that documentation basically, and it's so much value that we brought, which I was really happy about because this was a really fun task for me to work on. This is truly like solving a puzzle. So yeah, so here you have another example. C'est une valeur simplifiée. And so here you have the accent aigu that was added. Same thing here. Gérer la variable. So yeah, and this works also here in the Java docs or
Very
in the
nice.
multi-line comments.
Right. Right.
Oh yeah, so there's that.
Very cool stuff. So what else? What other kind of cool AI stuff do we have coming up?
Yeah, we have 2 really cool stuff coming up. Not quite deployed, at least not to be usable from end to end, but that we're really, really excited about. The first one is basically a pipeline, a tool, a feature, however you want to call it, that permits you to search for method invocations, but in a way that's more vague than if you were to use, say, find method usages, that a recipe that we have, where you need to, know at least the library, the name, the arguments, and if you can get all 3, that'd be even better. You'll get less false positives for what you're looking for. But instead here, you can do a query, which is just natural language. And what's what kind of the problem that inspired us to do this was long time ago, Jonathan was tasked in, I think it was doing some migration or something like that for some company, and it was something about content type headers for HTTP requests, something like that. And so he said, okay, no problem. What libraries do you use? And so they said, oh, we use what are the ones? HTTP requests, is that one? Unirest.
Mm-hmm.
And then they didn't say about a third one. And so it was only once all the work was done that they found that they were using actually a third library for that as well. And that they had to basically continue. So the idea is like, could we just write a query that says, find me all instances where content type header is added to an HTTP request?
Mm-hmm.
And so that's the whole idea behind that, kind of motivated for this to happen. But this could be used also, you could say,
so you're talking about, so from understanding, you're talking about like how to do like a fuzzy code search when you're like, I want to see something like this, even if I don't know up front the exact classes or methods that might be involved. I would expect terminology like content type to appear regardless of the library in use. Okay, yeah, that makes sense.
Yeah, exactly. And even within the same library, I think it was Unirest or HTTP. I'm not the most familiar with Java enterprise code, but one of them you could add content type through .add and then put like a dictionary or something like content type and then whatever you wanted to put in. And then another one was add header and then you could put content type. And so there's multiple ways of doing the same thing. And if you're unaware of that, you might miss it when you're searching for that if you wanted to use a recipe for it.
Right.
And
yeah, with the traditional search tools or even Moderne, I'd be like, well, I know I'm looking for this class, this method, and naturally would not discover things that were similar but from an unexpected library. And I imagine that kind of fuzzy or ML-driven search would also kind of naturally be good at working across different languages. It wouldn't necessarily care about Java versus Python versus anything else. It would, yeah.
Yeah, exactly. We definitely use the LSTs and a recipe at first to guide us through it. So it does need to be, parsable in that sense, just because it's our way of making it faster. And well, actually, let me just show you how we do it.
Yeah.
Let's see. All right. Looks complicated. That's because it is. No, I'm joking. But it's not that complicated. There's just a lot of steps. So just as a reminder, the task here is based on a query, go find the method invocations that do that thing. So we have your code, LSTs, pass it down to the recipe. And basically that recipe is going to go find all method signatures for methods in use. So it goes, finds all the method invocations. And from that, it goes and grabs a method signature for all of them. So whether that's a third-party method or an in-house inside the repo method. And so it has basically, the return type, the method name, and the arguments. From there, classic embedding model, making a comeback. We get the embeddings for all of those. And from there, we take the query. So that would be like, find me all methods that blah, blah, blah. Embed that as well with the same model. And from there, we'd get a top K. So using that top K then, we generate a YAML recipe automatically. So to kind of give an example, here we might say, okay, so in the top, let's say top 3, just because I don't know how many examples I can come up with. In the top 3, you might have the dot, HTTP request dot add, HTTP request dot set content type, HTTP request dot, I don't know if I have another one, unirest dot add content type. So we'll have those 3. And from there, now we know the type or the library, We know the class, I should say. We know the method name. So now we can just use our recipe find method usages. And so we just generate a YAML, this composite recipes, which is, if your K is big, it's a really large YAML recipe. And we've now made this search space a lot smaller so that then we can go look at just the method invocations after. And this first step, which is interesting, is that this can all be cached as well. So the whole idea is to make it quick. The recipes are super quick, as we know. And that means that we're maybe left, say we had 50,000 method invocations in a repo. It's a large repo. And you get the top K, and those are used twice, the top 1,000, and those are used twice on average. Then you have only 2,000 method invocations to search after on this step here. And so this step here is uses 2 steps as well. And that actually uses a generative model as well, because we found that there was no model that was better than a generative model to say, are these 2 things related? And so we make it output yes or no. And, we do some prompt engineering to make sure that it prints it out the way we want. And after, we don't just get if it yes or no, we actually look at the probabilities for the different tokens. And then there's a first step as well, so that we don't have to call the generative model all the time, because those are obviously bigger and they take longer to run. And so basically this model then can tell you, okay, yes or no, was this method invocations related to the query? Give that back to the recipe, and then we get, either a data table or just regular search recipe on the platform.
That's very interesting. So if I'm following all of this correctly, you're describing a model essentially that translates a maybe kind of fuzzy search query into a very concrete, very specific search query that is implemented in terms of composite recipes. So you might ask, find me methods that do something like that do data processing of some kind, and then that would emit a YAML recipe with find method, com.foo.whatever, find method, find class, all in a sequence. And so that output of that model that then goes and runs as a fast recipe search it's something that a human could further refine. If the model, you look at the generated YAML recipe and we're like, oh, that class doesn't actually exist. Like, this part of the query is, the generated recipe is maybe nonsense or not quite right. You could, as a human engineer, touch that up and iterate on it.
The generated recipe isn't used with a generative model, though. So, because we can have basically, since we have the method signature, we can just take the class and take the method name.
I see.
So, but it's true that, I hadn't thought about this. Definitely a human can intervene here and say, oh, I know this class doesn't do that. Or,
they could further refine or take that output and be like, this is useful to me. Other people are going to want to do this exact search later. I'll put this in our organization's custom recipe module, so it'll be available for everyone hereafter. Yeah, very handy.
Yeah,
this kind of goes into a kind of a category or a special case of using AI or language models to generate recipes, to not do the code transformation itself or do the code search in this case, but give you produce the recipe or the starting point for a recipe that would achieve the search or transformation you're looking for.
Yeah, exactly. And we really like to think about AI in 3 different categories here at Moderne. The first one is human computer interactions, HCI. That's making the search easier. That's HCI. So that's like usability. Then we look at, so there's this line that someone wrote that we liked, which was, when ChatGPT got access to a calculator, or that it could run the Python code in the conversation and then look at the output of the code to verify if that was actually what the code was supposed to do. So that's called AI gets a computer, which is basically when those chatbots have access to tools and can become kind of like agents where they can take, turns and run stuff. And then there's the third one, which is when we have those recipes that use AI. That's when we call a computer gets AI, because kind of switch it around where you have the recipe that's guiding when to use the model. And we like that because A, it's efficient. 2, it's safe because it's not going to change anything in your code unless it has access to that, right? Which is not a guarantee when you to do a large refactoring using, a large, close your computer and go see if it worked after kind of refactoring with AI. I definitely wouldn't trust it. It's, it can change stuff that you wouldn't want it to.
For sure.
It has a tendency to, yeah.
And that's why something like GitHub Copilot works so well, is that you have a human engineer right there who looks at the output and can make an informed decision about whether to accept it wholesale, modify it to be appropriate, or discard it.
Yeah, exactly. And you can't do that if you close your screen. So
exactly.
So I think this is the best of both worlds, where you have something you can save, but you can still use AI at scale. And then when we go back to this kind of, multi-step thing that, generates a YAML recipe, but as a rule-based generation, but that was based on AI. And you just have let's see how it goes. It goes, a computer uses AI, which uses a computer, which uses AI, which uses a computer. So it goes computer, AI, computer, AI, computer. And it's just let's just use the best of both worlds when needed. They have both their strengths, and, AI definitely has the ability to be, more generalist and kind of those human properties. But then when it's time to constrain it and to make sure to use it at scale, then we go back to recipes.
Yeah,
That's the
makes
beauty
sense.
of it. Yeah, that's how we like it. And
cool.
To finish off, then there's another project that's also in the works, which is going to appear in the Dev Center, actually, which is where we use generative AI to be able to go find recommendations of recipes based on your code base. So if we see that you're using, random versus secure random, or rather if the AI sees you're using random as opposed to secure random, it could recommend to you, hey, you should really, change that to secure random. Or if it sees that you're using something that, been deprecated since Java 17 or something, then it should say, hey, you could use this recipe to upgrade to Java 17, basically. And so that's going to come out in the Dev Center soon as well, which we're really excited about.
Very cool. Yeah, I look forward to that. That'll be really handy. Yeah, I think there's a really good path forward here for just more generally marrying fuzzier methods with analytical or deterministic methods, where they can compensate for each other's strengths and weaknesses. The strength of something deterministic and hand authored is, well, that it produces the same result reliably every time, and you can test it and establish great confidence that it will behave exactly as you expect it to. But then, those are expensive to create, maintain, debug, and test. Whereas something generative could be very, very fast, very easy to produce, but maybe with less confidence in its outputs. And so, using each of those where they make sense to complement each other. Well, I'm very excited for what we can do with marrying these kinds of techniques together, and very excited for your presentation next week at DevNexus.
Thank you so much. Yeah, it's all about aces and places. That's the sentence I go back to always.
There you go. Yeah, that's cool. Well, all right. Well, thanks so much for joining me during these community office hours, Justine. It's been lovely to have you and to learn a little bit more about this stuff. So,
Of course.
thank you very much. And
Thank you for your questions. You're always have such great questions. I really appreciate it.
yeah, yeah, happy to be here. Well, all right. Well,
Perfect.
thank you and everyone else for coming. This has been another community office hours, and I'll see you this same time next week. Until then,
Yeah.
bye for now. But I'll see you on our community Slack and Discord, and of course in GitHub issues and the like. So goodbye now.
Goodbye. Don't forget to like and subscribe.
Yeah,
That's
exactly.
what they
Like and
say.
subscribe. Yeah, that we're on YouTube after all, so you got to smash that like button, hammer the bell, and all that other good stuff.
I don't know when's the next time I'm going to be on a YouTube live, so this is my chance for it.
Yeah, yeah. Well, I mean, after this takes off and gets a million views, you'll have to go create your own YouTube channel.
I love it. Perfect. We'll do it.
All
All right.
right.
Bye,
Bye,
Sam. Thank you
everybody.
again.
Bye, Justine.